All right, this will be Module 3, Homework 2, which is talking about rational exponents. Before we start, this word rational, that is just a fancy word for fraction. So we're just looking at fraction exponents. So if you notice, there's two different ways of writing the same exact thing. We can write it in rational or fraction exponent form, or we can write it using radical notation. They both mean the same thing. So fraction exponent means a radical. So if we have x to the 7 over 10 power, that's the same thing as saying the 10th root of x to the 7th. So if you notice, a good way to think about it is this bottom number, this denominator, is the root. So just kind of like I think about a tree. So the bottom of a tree, the bottom of the fraction is the root. Boom, there's our 10th root. That 7's up top, it's going to stay up top as an exponent. So the 10th root of x to the 7th power, same thing. So in general, x to the a over b is the same thing as saying the bth root of x to the a power. Again, the b is on the bottom of the fraction, the bottom of the tree is the root. So the bth root, the a is up top, it's going to stay up top as an exponent. So these two things, again, mean the same thing, just two different forms, two different ways of writing it. So we are going to do this next example. It says use radical exponents. Let me go back, I'm sorry. Use rational exponents to write the radical. So again, we're going to use fraction exponents to write the square root of x to the 5th. Remember that if there's no index written, it's understood to be a 2. So our base is 5. To the 5th power. So that 5 is up top, it's going to stay up top, divided by our root, which goes on the bottom of our fraction, the bottom of our tree, is 2. That's it. We wrote it using rational exponents. We're done. Same thing for the next one. If we have the 5th root of 2x cubed, the 5th root of 2x cubed. So if you notice, this 3, this is where it gets tricky, this 3 is only applied to the x, not to the 2. The 2 doesn't have an exponent, so it's understood to be 2 to the 1st power. There's 1, 2 written there. So because these both have different exponents, we can think about them separately. So we can say the 5th root of 2 to the 1st power times the 5th root of x cubed. So now writing these separately, my base is 2. 1st power, 5th root, so that 5th root goes on the bottom, times x is my base, 3rd power, that power stays up top, 5th root, that 5th goes to the bottom. These are not like terms, so they cannot be combined. Boom, we're done. So because we are dealing with exponents, we have to go back to Module 2, Homework 5, which was all these exponent properties we talked about. So to be nice, because I'm a nice person, I made this little table. This table goes back and talks about all of our properties of exponents. So whenever we're multiplying a to the m times a to the nth, we're going to add our exponents. Here's an example. Whenever we're dividing a to the m divided by a to the n, we're going to subtract those exponents. Here's an example. A power to a power, so a to the m to the nth power, we're going to multiply those exponents. Here's an example. If we have ab to the mth power, that means a to the m times b to the m. Same thing with division, a divided by b to the mth power, so a to the m divided by b to the m. Examples. And lastly, we have this new one that we just talked about, so we can add it to our chart of exponent properties. If we have the rth root of x to the p power, remember we have x, p is up top, it's going to stay up top. Our root of r is going to go to the bottom. Here's an example. So everything you need to know about our properties of exponents in one little chart. So let's use this to do these next examples. So simplifying, I have x to the 1/3 to the 2/5 power. So because I have a power to a power, we are going to multiply these exponents based off that chart that we just talked about and the properties of exponents we went over in Module 2, Homework 5. So we're going to multiply these exponents. So we have that base of x, which is going to stay the same, 1/3 times 2/5. We're multiplying fractions, so we're going to multiply straight across. So we have x. 1 times 2 is 2, over 3 times 5 is 15. 2 over 15 cannot be simplified. Final answer. Our next example says use radical notation to write 4m to the 1/4 power and simplify if possible. Again, be careful because that 1/4 power is only applied to the m. That 4 doesn't have an exponent, so I know there's 1 4 there, so I know it's 4 to the first power. So 4 to the first, m to the 1/4. So 4 to the first power, just 4, just hanging out. The m has a fraction exponent. A fraction exponent means that's going to be a radical. Using my radical symbol, my base is m. First power is going to stay up top. That 4 is on the bottom, so it's going to be the root, and it's going to become my index. So I have 4 times the 4th root of m to the first power. There's only one m, so I can't take out a group of 4. Be very careful because this 4 is out front, so it's a regular size 4. This is my index, so this index of 4, the 4th root, goes inside the radical, so be very careful when you're writing it. And that's our final answer. Same thing for the next one. This time I have using radical notation to write in parentheses 49x to the 8th to the 1/2 power. So because it's in parentheses, that means everything has that 1/2 power applied to it. Because it's a fraction exponent, it's going to be a radical. So we have 49, x to the 8th is all of our base. First power, that 1's going to stay up top. That 2 is on the bottom, so it tells me it's going to be the square root. So just rewriting this, I have the square root of 49x to the 8th. And now it says simplify if possible. I can break down 49 into 7 times 7. 7 cannot be broken down any further, so it gets circled. If I have 8 x's, I'm taking out groups of 2. You can either write 8 x's and circle groups of 2, or we know our little shortcut, which we can divide. 8 groups, we're taking out groups of 2. That'll tell me 4 groups are coming out. So underneath the radical, we have 7 times 7, and then we have that x to the 4th is coming out. Those 2 7s are coming out. The x to the 8th we said was coming out as groups of 2, so 4 groups are coming out. So 7x to the 4th is our final answer. 7x to the 4th is our final answer. Same thing for the next one, using radical notation to write -27 to the 2/3 power. So because this -27 is in parentheses, that means everything has that 2/3 power applied to it. It's a fraction exponent, so we know it's going to be a radical. -27 is our base, so it's going to stay our base. Power of 2, 3 is on the bottom, so it's going to become our root. So we have the cubed root of -27 squared. So -27 times -27 will give us 729. It says simplify if possible, so we're taking out groups of 3. So let's start off 729 divided by 3 is 3 times 243. 3 cannot be broken down any further, so it gets circled. 343 is 3 times 81. 3 is done, so it gets circled. 81 is 3 times 27. 3 is done, so it gets circled. 27 is 3 times 9. Again, 3 gets circled. 9 is 3 times 3. We broke it down until it cannot be broken down any further. So we have the cubed root. Underneath the radical, we have 1, 2, 3, 4, 5, 6 3's. So the cubed root of 3 times 3 times 3 times 3 times 3 times 3. So we are taking out groups of 3. So these 3 3's are coming out of the radical, just as 3. And these 3 are coming out just as 3. Nothing's left underneath the radical. Everything came out in a group, so the radical's going away. We're left over with 3 times 3, which is 9, and that's our final answer. Next one, using radical notation to write -16 to the 3/4 power. So that 3/4 power is applied to everything in the parentheses. So because it's a fraction, we know it's going to be a radical. -16. 3 is up top. It's going to stay up top as our exponent. 4 is on the bottom, so we know it's going to go to our root. So we have the 4th root of -16 cubed. So -16 times -16 times -16 will give us -4096. So starting off, we know we can break this down into -1 times 4096. -1 can't be broken down any further, so it gets circled. 4096 can be broken down into 2 times 2048. 2 is done, so it gets circled. 2048 is 2 times 1024. 2 gets circled. 1024 is 2 times 512. I'm running out of room. 512 is 2 times 256. 2 is done, so it gets circled. 256 is 2 times 128. 2 is done, so it gets circled. 128 is 2 and 64. 2 is done, so it gets circled. This is in my way, so I'm just going to get rid of it. 64 is 2 times 32. 2 is done, so it gets circled. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. 4 is 2 and 2. Whew, finally done. A lot of 2's. Let's go back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2's. And then we have that negative. So underneath the radical, instead of -4096, we know we can rewrite this as -1 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2's underneath the radical. So because it's the 4th root, I don't have anything for the 4th root of -1. I only worked for the square root, and we can only break down that negative if the index is odd, which in this case 4 is even, so I can't do that. So it's just going to stay there. But I can take out 4 of a kind with my 2's. So these 4 2's are coming out. These 4 2's are coming out. And these 4 2's are coming out. So outside the radical, we have 2 times 2 times 2, which is 8. Underneath that radical, underneath that 4th root, we still have that -1. So it's going to stay underneath the radical. And that's our final answer. So 8 times the 4th root of -1 is our final answer. Next page. So writing with positive exponents, we have -64 to the -2/3 power. All it says, if you read the directions, is write with positive exponents. So in order to make this -2/3 is applied to the -64. In order to make it positive, it's up top, it's going to flip down to the bottom and become positive. So we now have -64 to 2/3 power. Nothing's up top, so I have to write a 1. We now have it with positive exponents. Done. So remember, negative exponents flip. So either top or bottom. So this one's up top, it's going to flip down to the bottom. If it was already on the bottom, it would flip up to the top. So same thing with the next one. This one says write with positive exponents, and then we have to go further and simplify. So I have 6 over 5x to the negative 1/2 power. So that negative 1/2 power is only applied to whatever's directly underneath it. So it's only applied to the x. So in order to make this positive, it's going to flip. It's on the bottom, so that means it's going to flip to the top. That 6 is already up top. It's just going to hang out. X 1/2 power over 5. 6 and 5 are our only like terms. They cannot be simplified. There's something that goes into 6 and 5. So this cannot be simplified any further. We wrote it with positive exponents. Done. Next example, using our properties of exponents, we are going to simplify 5 to the 3/5 power times 5 to the 1/10 power. So because they are both base 5, they are like terms. Using our properties of exponents, going back to this chart that we talked about, just like this example, if we had 3 squared times 3 to the x power, we're going to add our exponents. We're going to add our exponents. So same concept. Because they have the same base and we're multiplying them, we are going to add our exponents. So we're left with 5 to the 3/5 plus 1/10 power. So in order to add 3/5 plus 1/10, we have to make them like terms. We have to get a common denominator. So our LCD in this case should be 10. In order to make 5 10, I need to multiply by 2. What you do to the bottom, you have to also do to the top. This second fraction already has a denominator of 10, so it's already good to go for us. So we have 5 to the power of 2 times 3 is 6, over 2 times 5 is 10, plus 1/10. Now these are like terms. 6/10 plus 1/10 will give us 7/10. This 7 over 10 cannot be simplified. Boom, final answer. Next example, if we have to simplify b to the 3/4 power times b to the 1/5 power, all over negative b to the 1/2 power. So this looks like a lot. For one, they're all b's, so they're all like terms. So let's just do one thing at a time and try to simplify them. So starting off, let's simplify this numerator. So b to the 3/4 power times b to the 1/5 power. So they're same base, they're both b's, and they're being multiplied together. So we are going to add the exponents. So we're left with b to the 3/4 plus 1/5. We're not even touching the bottom, so we're just kind of bringing it over so we don't forget it. So looking at the top, 3/4 plus 1/5, these are not like terms. I need to make them like terms to get a common denominator. So out of fourths and out of fifths, our LCD should be 20. So I need to multiply this fraction, top and bottom, by 5 to make that denominator 20. And the second fraction multiply by 4, top and the bottom, to make the denominator 40. So we're left over with b, 5 times 3 is 15, over 5 times 4 is 20, plus 1 times 4 is 4, over 5 times 4 is 20. Now these are like terms. B to the 15th plus 15 over 20 plus 4 over 20. That'll give us b to the 19 over 20. 19 over 20 cannot be simplified. We're still just bringing over this negative b to the 1/2 power. So because we simplified the top to b to the 19 over 20, the top's done. Now we can worry about simplifying b to the 19 over 20 divided by b to the 1/2 power. So because they are being divided, we can subtract these exponents. We can subtract those exponents. So we have b to the 19 over 20 minus 1/2 all over that negative 1. Don't forget that negative's down there still. Again, 19/20ths minus 1/2. We have to get a common denominator, which in this case our LCD should be 20. So we're going to multiply the top and the bottom by 10. This one's already 20, so it's good to go. This one just needs, we can change it into 20. So it'll give us b to the 19 over 20 minus 10/20 over that -1. Don't forget to move it over. So now we have B. 19/20 minus 10/20 will give us 9/20. 9 over 20 cannot be simplified, so that's done. Don't forget to bring over that -1. So we have B to the 9 over 20 divided by -1. So that'll just make it negative B to the 9 over 20th power. And that's our final answer. We can't simplify any further. Next example. All right, the next one is going to be simplify x cubed y to the 6th all to the 1/6 power over x to the -7 y to the -3 all to the -1/3 power. So we're going to start. There's a lot of stuff going on. Let's distribute these exponents. So just like last Module 2, Homework 5, that last page where we did all like the exponent properties, we're going to distribute the exponent and say x cubed to the 1/6, y to the 6th to the 1/6, all over x to the -7 to the -1/3, y to the -3 to the -1/3. So we have power to a power. So we are going to multiply the exponents. And in this case, we're multiplying fractions. So we're going to multiply straight across. That's how you multiply fractions. So we have 3, which is the same thing as saying 3 over 1, times 1/6. So x, 3 times 1 is 3, over 1 times 6 is 6. So 3 over 6, they both have a 3 in common, so we can simplify this by taking out or dividing by that 3 on the top and the bottom, and we have 1/2. Next, we have y to the 6th, which is the same thing as 6 over 1, times 1 over 6. So y, 6 times 1 is 6, over 1 times 6 is 6. 6 divided by 6 can simplify down to 1. Divided by, same thing, -7, which is -7 over 1, times 1/3. So x, -7 times -1, +7, 1 times 3 is 3. Y, -3, which is the same thing as saying -3 over 1, times -1/3. -3 times -1 is +3, over 1 times 3 is 3. 7/3 cannot be simplified, but 3 over 3 can simplify down to 1. So it still looks like a lot. So let's rewrite it over here a little bit simpler, a little bit nicer, a little bit neater. So we're left with x to the 1/2 power, y to the 1st, which is just y, over x to the 7/3 power, over y to the 1st, which is just y. So if you notice, y divided by y cancel each other out. And we're left with 7 to the 1/2 power divided by 7 to the x to the 1/2 power divided by x to the 7/3 power. So because they're both x, or like terms, because they're being divided, we are going to subtract our exponents. And we are left over with x to 1/2 minus 7/3. So in order to subtract 1/2 minus 7/3, we need to get a common denominator. Our LCD in this case should be 6. So this fraction is missing a 3 from the top and the bottom. The second fraction is missing a 2 from the top and the bottom. So we are left over with x, 3 times 1 is 3, over 3 times 2 is 6, minus 7 times 2 is 14, over 3 times 2 is 6. Now we have 3/6 minus 14/6. So we're left over with x to -11 over 6. Last thing, we can't have negative exponents. So in order to make the exponent positive, it will flip down to the bottom. So x to 11 over 6, nothing's up top, so we're going to write a 1. So 1 over x to 11 over 6 is our final answer. So note, we cannot have negative exponents. So that's our final answer for that first problem. Next, we have to simplify the fifth root of y times the fourth root of y cubed. As of right now, these are not like terms. I have fifth root, I have fourth root, not the same thing. But we notice that they're both base y. So we're going to rewrite them using rational exponents. So this is y, fifth power, first root. Y, fifth power, so that goes on the bottom, first power, fifth root. Y, third power, fourth root. They're being multiplied together. So now they're like terms because they're both y's that are being multiplied together. So we are going to add our exponents. And that'll give us y 1/5 plus 3/4. These are not like term because we have fifths and we have fourths. So in order to combine them together, we have to get common denominators. So our LCD should be 20. This fraction's missing a 4. This fraction's missing a 5. So we have y, 4 times 1 is 4, over 4 times 5 is 20, plus 3 times 5 is 15, over 4 times 5 is 20. So now we have 4 20ths plus 15 20ths, which will give us y to 19 over 20ths power, which is simplified. The only thing is our question was written in radical form, so our answer has to also be in radical form. So it's fraction exponent, so we know it's going to be a radical. My base is y, 19th power, 20th root. Final answer. So to simplify, the fifth root of b to the fourth divided by the seventh root of b. Same concept. I have the fifth root and I have the seventh root, so they're not the same like terms, but I can write them with fraction exponents and make them like terms. So we have b, fourth power, fifth root, over b, first power, seventh root. So now they're both b's, they're being divided, so we can subtract our exponents. So we have b to the 4/5 minus 1/7. Again, we have to get an LCD, which in this case should be 35. So this fraction is missing a 7 in order to make the denominator 35. The second fraction is missing a 5 to make the denominator 35. So we're left over with b. 7 times 4 is 28, over 7 times 5 is 35, minus 1 times 5 is 5, over 7 times 5 is 35. So now they're both like terms, they're both out of 35. So we're left over with b, 28 35ths minus 5 35ths will give us 23 35ths, which that fraction cannot be simplified, but because our question was in radical form, our answer also needs to be in radical form. So fraction exponents means the radical. My base is b, 23rd power, 35th root. Final answer. Last one for this section. To simplify, x to the fifth, y to the fourth, to the 1/6 power, over x to the -5, y to the -2, to the -1/3 power. So exactly like that last problem it's the first problem we just did. We are going to start by distributing our exponents. So we have x to the fifth to the 1/6 power, y to the fourth to the 1/6 power, over x to the -5th to the -1/3 power, y to the -2 to the -1/3 power. It's a power to a power, so we are going to multiply our exponents. We're multiplying fractions, so we're multiplying straight across. So I have x. 5 is the same thing as saying 5 over 1. So multiplying across, 5 times 1 is 5, over 1 times 6 is 6. 5 over 6 cannot be simplified, so that one's done. Y, same thing, 4 over 1, so multiplying across, 4 times 1 is 4, 1 times 6 is 6, which 4 over 6 can be simplified because they both have a 2 in common, to 2/3. Over -5, which is -5 over 1. X to the power, -5 times -1 is 5. 1 times 3 is 3. 5 over 3 cannot be simplified, so that one's done. Then we have our y, -2, which is -2 over 1. -2 times -1 is 2. Over 1 times 3 is 3. So rewriting this, we have x to the 5/6 power, y to the 2/3 power, divided by x to the 5/3 power, y to the 2/3 power. So if you notice, y to the 2/3 divided by y to the 2/3, they cancel each other out because they're dividing. So if we were to subtract 2/3 minus 2/3, we would get y to the 0 power. Anything to the 0 power is 1. I don't need to write that extra 1 in there. So lastly, just simplifying these x's, x to the 5/6 divided by x to the 5/3. Because they're being divided, we can subtract our exponents. So we have x to the 5 over 6 minus 5/3. In order to subtract these fractions, we have to get an LCD, which in this case is 6. The first denominator is already 6, so it's good to go. The second denominator is missing a 2, so we're going to multiply that to the top and the bottom. So we're left over with x to the 5/6 minus 5 times 2 is 10, over 3 times 2 is 6. So x, 5/6 minus 10/6 will give us -5/6. 5 over 6 cannot be simplified, but we can't have that negative exponent, so we're going to flip it down to the bottom to make it positive. There's nothing up top, so we're going to write that 1. So 1 over x to the 5/6 is our final answer. And that is Module 3, Homework 2.